So welcome everybody. My name is Ákos Horváth. My colleague István Rat is here. Sadly, Rodrigo Rizzi Star could not come. This talk will be about Massif, which is a kind of tool between Eclipse, a bridge between Eclipse and Matlab Simulink. As you can see, there are quite a lot of companies or universities, and this is a European project, which somehow are related to the Massif project, either by working in it or providing funding to work on it. So, as for the first slide, the outline of the talk will be quite easy, some motivation, how we started this work, because that's really important, and what are the constraints in which we had to develop this technology. I will provide you a very short overview on Massif, and then we will go into some online demo to see how it works, because an importer, exporter, you know, it's better to see what can it do rather than to talk about that. And finally, we have some conclusions. As you can see, these handsome-looking gentlemen were working on the technology. The Brazilian friends are always happy and smiling. The Hungarians are not as many. And at the start of the project, I really had quite a lot of hair. But as you can see, as it is finished, I have lost quite a lot. But I really hope at least the results are quite OK. I don't know how many of you are familiar with Matlab Simulink, because when starting doing this presentation, I was not aware that there might be people on this actual talk who has never seen Matlab Simulink. Please raise your hand if you know Matlab Simulink or you worked with that. OK, so my guess was quite OK. Matlab Simulink is based on Matlab, which is the prime product of MathWorks. And it is a multi-paradigm numerical computational framework. I would say it provides a very high-level language to define algorithms, matrix operation, algorithm development, and support data visualizations, and many, many more things. Simulink is built on top of that technology, and its main issue is to provide a kind of block-based diagram design and provide simulation capabilities over continuous system defined in this block diagram-based way. As far as I could go, the user base of Matlab Simulink is now over 1 million users. There is no official data I could get, but most important that embedded system developers, especially in the safety critical domains, are really using this kind of technology, and many things and IPs and large amount of work is already done in Simulink. Okay, so this is the input, Matlab Simulink. I won't talk about Eclipse itself because I really hope that at EclipseCon everybody knows about Eclipse. But let's see what's the motivation behind doing a bridge between MathWorks, Matlab Simulink, and Eclipse. Well, as again, this work just started as a yet another tool integration scenario where we had a project with Embraer where they really wanted to do an early hardware software allocation tool, which at the end provides an integrated Simulink model, which can be fed into the simulation platform. And before starting any kind of development, even design, they would like to check out the different architecture is provided by their function providers and different payloads for the aircraft that they are designing. So the input was low-level Simulink libraries, which put together would mean a complex system. And what they would really wanted to have at the end, this integrated hardware-software Simulink model, which contains these libraries, initiate them, use them, connect them, and then execute the simulations on the grid architecture. Why do they want to have Eclipse as a front end? Because the project we were working with them was the second iteration. They tried to do this technology within Matlab Simulink, but some of the features and capabilities of Matlab Simulink was not good enough for them, and they really wanted to have a hierarchical graph-based visualization for their hardware-software design. They really wanted to have on-the-fly model validation, and due to the fact that we went to Eclipse to provide the tooling, they needed to to receive a bridge, a generic bridge between Matlab Simulink models, let's say, and the Eclipse platform itself. If you are familiar with us or you have attended previous Eclipse cons, you might have heard about our technology, which is EMF inquiry. Some of the new features of the tooling was developed within that project. However, I will talk about only this part for the current talk. So let's see how it looks like. Massif, what are the main motivations and what are the main constraints we had to work when doing this technology? We had to provide import-export capabilities for both systems and libraries. We needed to have some kind of traceability support for the imported models, so export can be done in an incremental way, so only the changes will go back to the Simulink model, which would provide better performance. And also, it came out that multiple import options are required to be supported as different case scenarios or usage scenarios required a different way of importing the overall Matlab Simulink models. I will talk about that a little bit later. As an additional requirement, it was to provide an EMF representation within Eclipse. So the idea was there that if we provide a user-friendly EMF representation with automatically calculated derived features and additional supports, it would be easier to process that kind of representation and then go back to Matlab Simulink whenever it is only required to do that. One important factor that some of the available tools were not able to do is to work with the Matlab license server, which means that we need to connect to a running Matlab instance, okay? And finally, that was coming from the project itself. We needed to have a pure Java realization and in line with the EPL licenses, okay? But that was just project-specific constraints. So, how does the tool look like? I wouldn't want to go into too much details, but as you can see, we went old school when developing this technology because within Matlab Simulink, we need to start a server, and the server communicates with the Eclipse through Java remote method invocation, okay? So this is how the communication between the Matlab Simulink instance and Eclipse, or the Eclipse instance, is going on. Within Matlab Simulink, we use the Java Matlab interface. If you know about this interface, you know it's a relatively long story. However, I would say it works perfectly, so it's a huge job. What it can do that you have a direct access to the Matlab console and you can execute any kind of commands directly within the running Matlab instance, okay? Due to the fact that we have to initiate the server within a running Matlab instance, it works well with the license server because all the communication between the Matlab instance and the license server is done when you run the Matlab Simulink. And when it's up and running, you can do your stuff and then start the communication with Eclipse. As for the generic EMF meta model, the idea was to provide, translate EMF level operations to Matlab commands, okay? So we have a kind of generic eco representation, and the instance models are instances of that particular eco. And if I do changes, this command processor calculates what kind of operations are needed to be executed on the Matlab side in order to have a kind of synchronized way of representing the same Matlab system within Eclipse, okay? And traceability, which is right here, is based on fully qualified names, I would say. Matlab Simulink also provides this kind of mechanism for navigating through the hierarchy levels of your models, okay? Let's see the feature set. And for that, as I mentioned, I really want to demonstrate some basic stuff, what our tool can do, okay? If you cannot see something, please tell it, because I will be sitting here next to my computer, and I might not be able to get a good angle on the beamer itself, okay? So, this is a VMware image, okay? My old grandma always say, don't do a on-site presentation, online demo, not using an image, because you might get in some troubles if you are using your own host environment. So I just start Matlab Simulink. Many of you are familiar with its logo, I suppose, if you are working with that. We have one very simple script here. This is responsible for executing the server, initiating the server. There is a service name which is used to configure the communication. And here within Eclipse, as you can see, we have some demo models. However, if we go to the preferences, we have a special preferences page that's just for the Simulink, the Massif tool, and we have to provide the service name that is given by the server itself. And if we apply it now, the communication between the MATLAB instance and Eclipse is up and running, okay? To demonstrate that, here I have an official MathWorks demo project. I just open it. It will take a couple of seconds to load. And voila, here we have, this is a demo project which was based on an F-14 flight control system, okay? As you can see, there is an input here. Sorry, I will execute the simulation. There is no input, right? Execute the simulation. Yes. No result yet. Sorry. Okay, it's executed. This is the output we were looking for, and this is the input of the system, okay? And it means that if I change the stick as the input, the pilot g-force and the angle of attack changes, okay? This is just a simple demonstrator. So what we will do here is we just kick in the import Simulink model. However, sorry for that. There are preferences that can be set for importing the model. There are 4 different traverse modes, which defines different import characteristics or strategies how the model are done. Currently, we use the shallow one, and I will just demonstrate what does it mean. Okay, apply, and then import the model. Yes, the name should be, let's say 2, demo 2. Okay, there are filters that can be used, but that's not so important. And let's do the execution. As I'm using an image, it might take some time, and during that time, I would like to, I would like to continue my presentation, okay? What does these import modes really mean? Especially if you are not familiar with Matlab Simulink. Well, the shallow mode is quite simple. Whenever we have a separate model, let's call it system A, and there are blocks inside them, either hierarchical or any other way, they are connected to each other, but in certain places we can have model references, which means it refers to another model, which can be imported into your base system in which you are working, okay? Shallow, as its name, as based on its name you can guess, means that it only imports the model itself without traversing the referred models themselves, okay? So not big deal here. And it doesn't do anything with the libraries also. On the other hand, there is the deep option, which means that, okay, if there are model references, those are also imported into Eclipse, okay? And there will be the same reference between the model reference block and the newly imported referred system, okay? These are stored in separated models. That's why they are in different blocks, okay? So if you are familiar with EMF, these are different resources, okay? However, in certain situations and case studies, it might be required that I do not really want to have this kind of referencing mechanism in my model. I would just like to have it in a flattened way, so I will have only one system, and all the models which are referred from my base model are copied into my model. So at the end, I will have one huge model which contains all the referred models. Don't forget, it might be possible that you have multiple references to the same models. In each situation, it is copied. It is copied into the overall system. This can be useful, especially in case of, for example, the allocation scenario, where maybe the same system, let's say, defining one functionality, but due to the fact of dependability, you might require multiple instances. All instances will be available in the final system, and those might be allocated to different hardware elements or execution nodes. And the final stuff is the reference importing option, which is quite useful. It means that it not only works on the model references, but it will also work with the library links. And that's a really powerful feature, because Matlab Simulink is based on the idea that you define libraries and instantiate the elements of the libraries in your system. Okay? This is a kind of different way how it handles like the model references, and everything within a Matlab model, even the basic elements, are an instance of a particular library element. So the basic block and something like that is also an instance of a specific element. Okay? So these are the 4 import options currently we are supporting. However, if there might be needed some additional way, well, it's relatively easy to define new import mechanism. Okay? Let's see what we have here. Well, we have its EMF representation. Raise your hands if you're familiar with EMF. I don't know. Okay, so cool. It's better that I don't have to talk too much about that. So you can see it's just an instance model. Okay. What we will do now is, okay, I just close the model within within Matlab Simulink. I will delete this representation here, and just would say export Simulink model. Okay, it will be exported with another extension, the older file format that is supported. And now it also takes some time, but it's a little bit faster than the import stuff. As you can see, currently, one by one, all the comments are sent from the Eclipse command evaluator into the server side. On the server side, through the Java Matlab interface, it executes that command, returns the value, and then the next stuff can be done. Okay, so this is just the basic feature. And now we have the MDA representation. And this is the same model. However, currently we don't have a built-in layout mechanism. Okay, so that's why all the elements are just put each up to a random, I wouldn't say random order, but in a very simple line-based layout. Okay, but there is an extension mechanism through which you can add layouting algorithms, so you can have at the end some decent representation. I will do the simulation again, and as you can see, it returns the same value. So this is a new representation of the same model that was imported, and now I just export it back, and as you can see, it works. For the same input, don't ask me to find it where it is, but for the same input, it provides the same output. Okay? Well, it works, it means. I really hope you enjoy also this part. So let's go back to the presentations, okay? I just wanted to demonstrate this one, okay? There are demos for the different importing modes, okay? If somebody is interested, I can demonstrate that, but I think it's not so important to see and wait that, okay, new EMF representation just pops up, okay? There are additional features that might be interesting for you. One is the import filters. In many cases, you don't really want to import the complete model, only just a certain part of it. Let's say the high-level architecture, or you would import it to a certain level because below that, that might change through the model referencing mechanism or the library linking mechanism, or certain parts of a library element might change. And for that reason, simple filters or filters, an extension point is added so you can define whatever filter you would like. Also, I wouldn't go into details, but this is a really tricky part of Matlab Simulink, bus creators and selectors. It is a string-based, again, fully qualified name-like configuration is required to work properly. Within Matlab, it's worked well to have this kind of bus creators and selectors. However, third-party tools do not really know how to calculate these configuration strings. And we have added this feature into our EMF representation. So you can have nicely defined e-references that within that bus, that is the link I would like to see. And it can calculate the required configuration string when you export it back to the Matlab Simulink representation. And finally, there are some navigability helpers on the EMF representations, which provide you the capability to provide, let's say, reachability and related stuff, which is also supported by Simulink, but it can work through all the libraries and model referencings and whatsoever. Okay? A few words about the OSLC API we have just defined. I don't know how many of you are familiar with the Open Services for Lifecycle Cooperation initiative. One guy? So, two? Well, not too many. Okay. The idea here is that this will provide a very nice interface for integrating different tools together. Okay? This is an OSATE, as far as I can, an OSATE initiative. It is a standard. The reference implementation is based on Eclipse-LIO. Okay? It is based on the concepts of REST APIs, RDF, and link data, which is a kind of web-based technologies. But these can be quite effectively used to integrate different kinds of tools together. And we have provided this kind of feature also to Massif, using the same mechanism for the Matlab command evaluator server and the command evaluator. And we just use Eclipse-LIO to provide the required interfaces. And with that, you have the ability to have a live OSLC API for Matlab Simulink, which means that it always executes the commands whenever I'm checking some kind of querying for some kind of information. And if you are familiar with the OSLC, the official Eclipse-LIO demonstrator also is a Matlab Simulink OSLC API. However, it doesn't use this kind of live mechanism. It just receives all the information from networks once, and then reads that information and provides that information. So whenever there is a change, it will not know. You have to initiate again the re-execution of all the importing feature or importing support that it provides. However, in our case, this is live. So whenever I'm checking for some new query, it checks how it looks like in Matlab and receives that information. Okay? Then again, just to show that it works. This is the configuration file for the OSLC service, okay? I add the link I have, okay? So this is the ID I require to be able to communicate with the Matlab instance, okay? Sorry, I don't need this. Here we have a startup script. seems it's worked. And voila, this is the REST API-based JS page that we can see, okay? This is not how it should be used. Usually OSLC API should be, you know, code directly and not mainly for human users. But we can see if we have a demo there, we can go inside. Here we have another querying support to have all the different types which are inside our model. And if you're interested, we can see the model itself right here. And it provides the same hierarchy-based traversal as MathWorks itself. So we have the different elements as defined right here. And if we are interested in certain elements, let's say here we have a subsystem resource. We can go inside and see what's inside them, and all the information, properties, and everything is there right there, okay? Using the REST API and visualizing as it should be, okay? So these are the main features that the tool can do. And let's have some conclusions. So the initial version is out, I would say. Basic import-export features are supported, and Simulink's models can now be handled on an EMF level. What experience we have with that, and that's a huge question as always. Well, within one scenario, we were working with an avionics company. The largest model took almost more than 2 hours to import, but that was a complete flight management system, hardware, software definition of a new aircraft, which as far as I can remember, it had its maiden flight a few months ago, end of 2014. Okay, it was an enormously large model. It took almost 100 engineers a few years to define it. Okay. On an automotive scenario, there was a relatively large model containing approximately 5,000 elements, blocks, and stuff like that, and it was done within minutes. I wouldn't say this is super fast, but within the acceptable range. Especially if the typical application scenarios for the tool, as if, is that we would like to have some offline processing of the EMF representations, or we use that, or we are just requiring some part of the information that is stored in the Matlab Simulink representation and then work on that later on, okay? And the other typical scenario is that we only import the libraries themselves, and then on the EMF side, do the instance model generation, okay? So we have the library information, how they look like, which kind do I have, what kind of ports and information I have about it. I will generate the instance representation on the EMF side, a huge EMF model, because we have a lot of technologies for that, and then export it back to Matlab Simulink. So these are my final points. It's available on GitHub. Version 4.0.5 is already out. Main contributors are our university and Embraer. This company provides some help, and also it is these two projects are the main projects that's funding this kind of tooling. Try it, please. We try to provide as much documentation as possible, so you can read it, test it, and any kind of feedback, forum post ideas are welcome. And I would like to hear from you. What do you think? To what direction should we enhance Massif? Okay. Thanks for your attention, and if you have any questions, feel free to ask. Okay.
EMF is import-export mechanism, as I have seen it.
No, it's better to say it's the information representation within Eclipse. This is how we represent the Matlab Simulink models as an EMF model.
But you don't edit, when you edit the EMF, you have to push it.
Yes, it's not that incrementally synchronized. So you always have to say at one point, okay, push it back right now.
Is it for OSLC? Because it looks like it.
Sorry, is it?
For OSLC? For your OSLC bridge? Is it synchronized
No, the OSLC bridge works in a way that when you trigger a particular query, okay, asking something, then it goes to Matlab, execute what it should know, provides back the information, and then it will give you the information through the OSLC API. Okay, so that's why I'm saying it's live. So it's always goes to the Matlab to the Matlab Simulink, does what it needs to done there, and returns the information from there.
If I only need read-only, should be easier with that, so you don't have to synchronize stuff with
Yes, if you need read-only. So if you are sure that nobody will change the model from within, let's say, Matlab Simulink itself, yeah, there is an easier way to do that. So you don't need this kind of two-way live synchronization. Okay. Any other questions? Thank you. Please don't forget to evaluate the session, as it is important to receive feedback, okay? And if you have any questions, I will be around, so just come to me and we can talk about this tool. Thank you.